What is percentile? It's a statistical term just like mean, median, mode, range, etc. Some of these are measures of the central tendency of the dataset, but percentile is a measure of relative position of data points within the set. Why percentile is used for grading? Take an example of 1000 students. Suppose their grading is based upon the percentage of marks alone. A grade to those who got 80% marks or more, like that. Then see, if the examination is so easy, all the students got above 80% and A grade. On the other hand, if it is too tough, nobody got 80% and no A grade. In both cases, fair comparison or differentiation between the students who got good marks and low marks is not possible. So to make a fair comparison, percentile system is very much useful. Before explaining percentile, see these dividing methods of data points. 100% of data means there is no division line in the data set. 2 bins means one dividing point is there, which is called median. Median divides the total data points into 2 bins of 50% each. Next is 4 bins. That means 3 dividing points which divide the total data points into 4 equal parts. These 3 points are called quartiles. So there are 3 quartiles, Q1, Q2 and Q3. Next is 10 bins. It divides into 10 equal bins by way of 9 points called deciles, D1, D2, D3 like that up to D9. Each decile is having 10% of the data. Next is 100 bins, means 99 points divide the total data points into 100 equal bins of 1% each. These 99 points are called percentiles, about which we are going to study in detail in this video. These 99 points are first to 99 percentile. Now we learned that certain points divide the total data set into equal parts. These points are called quantile. 2 quantile is median, 3 quantile is tertile, 4 quantile is there, that is called quartile, 10 quantile is decile and 100 quantile is percentile. Here some of the differences between percentage and percentile are listed. Now let us see how to calculate percentile in a simple way. First, list all the data points in ascending order. Then allocate rank number from 1 to n, block n, where n is the total number of data points. Then percentile of a particular data point equals number of data points below the given value upon n into 100. This is the formula. See this example. Total 12 data points are there. Our first question is, what is the percentile of 36? 36 is a value among these data points. So see, 36 is at the rank of 10. So number of data points below this point is 9. Therefore percentile of 36 is equal to 9 upon 12 into 100 equals 75. Our answer is 75th percentile. The second part of the question is, what is the value at the 50th percentile? So let us take n is this corresponding rank for 50th percentile. Then n minus 1 upon 12 equals 50%. From here we can calculate n. N is equal to 50 into 12 upon 100 plus 1, that is equal to 7. That means data point at the rank of 7 is of 50th percentile. From the table it is clear that the value is 31. While calculating percentile, most of the time fractions will come. Then it will not be easy as done in the earlier cases. See this case of total 12 data points. For 80th percentile, 80% of the data is to be identified. Do 0.8 into 12 equals 9.6. It is the rank for the limit. That means the required data point is in the bin next above this rank of 9.6. The bin only identified now. The exact position we have to find out within that limit, within that bin. For this purpose, we have to do interpolation method. Now, how to interpolate? First step is to calculate P upon 100 into n plus 1. P is the percentile, n is the total number of data points. Here we use n plus 1, not n. Why is this? It is explained here. See the pink area. P upon 100 into n gives the rank position above which the required bin is coming. Location of the bin only identified here. But within that bin, where is the exact location of the required data point falls? To see that, again multiply P upon 100 with the bin size. Here it is 1. So P upon 100 into 1 gives P upon 100. Now the exact position of the value is equal to sum of these two ranks. That is P upon 100 into n plus P upon 100 gives P upon 100 into n plus 1. If it is not clear, please see the next slide. With a close view of the bins, it is explained. Here, a close view of the bin number 80 is given for easy understanding. Case is 80th percentile of a data set of n equals 100. When we multiply 0.8 with n, that is 0.8 into n, gives the rank as 80. It implies the required 80th percentile falls in the bin just above this 0.80. Within that bin, where exactly the 80th percentile comes. To see that, multiply 0.8 with the bin size, that is 1. That is 0.8 into 1 gives 0.8. Then add both ranks. It gives 80 plus 0.8 gives 80.8, which gives the exact position of the 80th percentile data point. Hope it is clear now. Few examples are illustrated here. Total 12 data points. That means n equals 12. To find 80th percentile, first calculate P upon 100 into n plus 1. That is equal to 0.8 into 12 plus 1. 0.8 into 13 gives 10.4. Now 10.4 falls in between 10 and 11. See the chart. 10.4 falls in between 10 and 11. Corresponding values are 36 and 38. See the blue colored numbers. So now do the interpolation like this. We know the rank is 10.4. We already calculated here. So how we are getting 10.4 plus, from 10 and 11? That is given here. 10 plus 0.4 into 11 minus 10 equals 10.4. Similar way we have to do for the value also, data value also. Data value means 36 and 38. Do the same method in between 36 and 38. So instead of 10 we will write 36. 36 plus 0.4 into, instead of 11 you write 38. Minus, instead of 10 again you write 36. 38 minus 36. This gives the value we can calculate. It is 36.8. So this is the 80th percentile. 36.8 is the answer. If not clear, read once again by pausing the video. Some more examples are following. In this example, total number of data points is equal to 20. That means n equals 20. What is the 90th percentile? That is the question. First calculate the rank. 0.9 into 21 means n plus 1. That gives 18.9. Now we have to interpolate for this value. 18.9 falls in between 18 and 9. Corresponding data values are 47 and 46. Both are same. So how to do the interpolation? Rank 18 plus 0.9 into 19 minus 18 gives 18.9. All the values we know earlier. Now corresponding data value we have to give. Then we will get 47 plus 0.9 into 47 minus 47. So the answer will be 47. That means 90th percentile is 47. Now the next question is, what is the percentile for a data value of 43.6? Here reverse interpolation is to be done. Means data value already given, corresponding rank is to be calculated. So first write for data value 42 plus 0.8 into 44 minus 42 is equal to 43.6. So the given value 43.6 we express in this way in terms of the non-data value points, means 42 and 44. These are standard values there. 42 without fraction, 42 and 44. So in between where this 43.6 comes, that we have to write in this way. 42 plus 0.8 into 44 minus 42 is equal to 43.6. Corresponding values we have to give for rank. That is 16 plus 0.8 into 17 minus 16. These 42 and 44 corresponding ranks are 16 and 17. So our answer will be there in between 16 and 17. So interpolate in the same way. Reverse interpolation. Corresponding percentile will be 16.8. Means 16.8 is the rank. So corresponding percentile will be 16.8 upon n plus 1. N plus 1 is 21. So 16.8 upon 21. The answer is 0.8. That means it is 43.6 is at 80th percentile.